Hello again, higher algebra students, back with you for another Unit 5 lesson here on solving systems using a calculator. And we are actually going to use an online calculator here from Desmos.com. Um, you can also use a graphing calculator, which I'll touch on at the end as well. So this got a little goofed up here, but this is solving systems using a calculator, which is actually day 5 now in our unit. And then we're going to use Desmos here. So we'll jump. So here on Desmos.com, right at the top of the landing page is a little blue tab to tap on graphing calculator, click on graphing calculator. So when you click into that graphing calculator, it comes to a screen that looks like this, where you have a coordinate grid. You can see down here, depending on what device you're working on, if it's an iPad or a laptop or whatever, this allows you to bring up the buttons for where you type in if it's X or Y or the numbers and things like that. And so what happens is there's the number screen kind of over in the bottom right that has the digits 0 to 9 and the addition, subtraction, multiplication, division, so forth. And then on the left side, there's an area where there's a Y and an X. There's an absolute value, which we're going to use a little bit of. And so that part, like I said, depending on device, it may show up automatically, or you may have to click on this little keyboard in the bottom left to bring that up. And what you're going to do then is you're going to type equations, and I always like to type y equals, but you can actually get away without having to do that. But you'll type in equations into this, and then you can either take your cursor and click right below it here to get another graph up, since we're going to be graphing at least 2 each time. Or there's a little return button down here that has a little arrow like that that allows you to move down to the next one as well. Um, so when you type in these equations, the graphs will show up over in the coordinate grid. And again, you can see I typed in y equals. If you don't type in y equals, I think you'll find that it's still fine. And then once the graphs are on the coordinate grid, you can hover over the graphs and click on them. And for instance, you can see I've clicked on the red graph in this one. And on the red graph, then it shows 3 dots. And the 3 dots that it shows, one is on the y-intercept and one is on the x-intercept. And that's fine. That's information that could be useful at some point. But for us right now, what we're interested in when we get both graphs on there is this point right here where those 2 lines intersect. Okay, where they intersect, that is the solution to our system of equations. So that's the point we're interested in. And the only thing you have to do there is just to make sure you're cognizant of the number of decimal places. Okay, so if it is negative 1.05, and if it says 1 decimal place, you might take that negative 1.05 and then round it to negative 1.1. And if you get 3.3, then that can stay as is. Or if it needs to be 2 decimal places, then that might be 3.30. So just be mindful of that. So here's an example from Desmos here. So we have 2 equations. We're trying to find the solution to this system of equations right here. First thing you have to be careful with is how you type in this. Depending on the program, if you type that in without parentheses, it may read it like that instead of what is intended here, which is negative 4/3 x. So the slope is meant to be negative 4/3. But certain programs, and I believe Desmos could be one of them, will read this as negative 4/3x. And that's, of course, different than what we're seeing here. So just be mindful. You can see what I did is I put a parentheses here. So I did a left parentheses, put negative 4 divided by 3. Then you might have to do a right arrow because it's going to try and give you a parenthesis there. Do the right arrow to make sure your parenthesis is the whole thing. And then put the x and the plus 2 there. And that will graph this blue line here. And then I hit either return. So return's kind of in the bottom right on Desmos. If you hit return, it will bring you to a second option, or you can just click right below the other equation and it will give you that second one here. And what you're going to do then is type in that equation, and that equation then gave me this green line. And after I type in both equations, I click on one of the lines, and you can see I had clicked on the green line here, and it gives me the x-intercept of the green line, but it also highlights this point of intersection. And that point of intersection is something like negative 1.059 and 3 point something. So I can look quickly, it's 3.412. And these are rounded, and so you do have to be mindful of how many decimal places it's asking. If it just wants 2 decimal places, then we'll actually write this as negative 1.06 and 3.41. If it just wants 1 decimal place, then you'll write this as negative 1.1 and 3.4. But that would be this point of intersection, and that point of intersection again is the solution to this system of equations. Now, second one here, this one is a little more complicated. As you can see, it has absolute values. Okay, so absolute value, when you click on and you get those keyboards on the bottom, okay, down in this part here is an absolute value. And when you click on the absolute value, it gives you this sort of space with a little gray space in between. You just click into that gray space and type in x plus 1 in there to get that absolute value. And you can see mine here. The absolute value shows up with the x plus 1, and then you click out of it and add in the -8 that's on there. So that led to this graph right here, this black or green, black, it looks like, absolute value graph there as well. And then you have to, you have the second one, and then the second one, you have to be careful that the negative is outside of a parentheses. Okay, so what is asked here is that, which is different than just typing in this. Okay, the negative out front turns this graph upside down, faces it downward like we have on this red graph. Whereas the negative out front will just make that original value negative, but then when you square it, everything turns out to be positive. So, so be mindful of that it is different when you have the parentheses in there. And again, I put in the y equals. It's okay if you don't put in the y equals, but that we get to the point where we then click on one of these two graphs, and when we click on one of these two graphs, as you can see, I had clicked on the red one here. Those 2 points of intersection now are notable. That's something that we maybe aren't quite ready yet without a calculator, but with a calculator, we can find systems where there's actually 2 answers instead of just one, and we'd type in both of those answers, the coordinates for each of those, and those would both be solutions to this system of equations. Now, if you do switch over to a graphing calculator, it can do much of the same that Desmos does, just a little different process. So on the graphing calculator in the top left, right below the screen, you'll see there's a y equals button. And that y equals button will bring you to a collection of y equals equations. And what you're going to do is type in the equations. Again, you can see this one does not have a parentheses around the 2/3. The calculator might pick up that order of operations, but I, again, am a fan of putting parentheses there. But it's a little different than Desmos in terms of how it will, the intuition of the system and how it sets up those fractions in front of a variable like that. So it probably would have been fine here, but again, the parentheses can be helpful. But then we graph, and when you hit graph, it leads to this screen right here where you get the 2 straight lines. And when we have those 2 straight lines here, what we're interested in naturally is that point of intersection again. So what we're going to do is go to the second button on our calculator and go to hit trace. And so second trace brings you to this screen right here. And on this screen, we're interested in that intersect, which is number 5. And what it will do when you click on that intersect is it brings you back to this graph, and it will ask you first curve. And of course, these aren't curves, but what it's just hinting at is the first line there. So you're going to use your up, down, right, and left arrows to go to either the red or the blue line here, or one of the two if it's not in color, that just one of the 2 lines that's there, and hit enter. Okay, and then you're going to again use your arrows to go to the second curve. Make sure the equation changes here, so you know you're on the new line, and you'll hit enter again. And then it's going to ask you to guess. And by guess, what it really means is get that point of intersection. It's not actually guessing in our work. But then you'll hit enter again, and it's going to give you that point of intersection. So you can see there's that negative 1.05, 3.3 again. And so what we're looking at there is that point of intersection for this particular set of equations, and that point of intersection then is your solution to your system. So you get that. Again, you be careful with your rounding, depending on what the question is asking in terms of decimal places. And we won't go through that again, but it could be asking for one, two, or three decimal places. So be mindful of that. But again, that point of intersection is your solution. Thank you as always for listening. And if you have questions, please ask.